All right, welcome everyone to the mold design training. Today we're going to start off with module number 1 being part selection. So I'm going to run you through kind of what you're looking for when selecting a part, things to look for, things not to look at. And then we're going to get into editing parts to prepare them for injection molding. And we'll take you all the way up to when your part is ready to be molded. So to start off, we're going to look at some molding limitations. So this is going to be strictly hardware-based stuff. So what is your molding press, what's your molding frame, things like that. So the first thing you're going to want to look at is your machine shot volume. So I'm going to use our molding press as a reference here, but we have a 30-ton Nisei press, which has a shot volume of 23 milliliters. So that's going to be my first kind of bounding box for what parts I can look at. You're not going to want to use the full 23 milliliters because you're not going to end up with a cushion. So that'll essentially ruin your molding process. So for this instance, we're going to look at about 90% of that 23 milliliters, which, done the math out, it comes out to about 21.75 milliliters a shot. So that would be my shot volume bounding box. From there, we look at our pocket sizes. So in the bottom image, we have our mold frame, and there's 3 different pocket sizes represented by the 3 different boxes. So we have our red pocket, our yellow pocket, and our blue pocket. So for this example, I'm just going to work with the standard pocket size being the red pocket. So for that pocket size, it ends up being 95.25 millimeters by 69.85 millimeters by 31.75 millimeters. So that's my overall block size, but that's not what limits me. What I need to do is apply a 10 millimeter offset to each of those dimensions, and that's going to get my bounding box for that pocket size. So for this example, our overall pocket size, our bounding box there is going to end up being 75.25 millimeters by 49.85 millimeters by 43.5 millimeters. So that last value, that's including both the A and the B half, the depth of both of those blocks. So I have my shot volume bounding box. I have my pocket bounding box essentially. And then we're going to look at our printer build area as well. So that's going to be kind of your third bounding box. And that's important, especially if you're using a frame that's larger than what we have. That could end up being your limiting factor. So the build area of the printer is 203.7 by 114.6 by 330 millimeters. So that is going to be your overall kind of bounding box on what the upper limit for an insert size that you can print is. But for our example, we're significantly smaller than that, so it's really not something we take into consideration. So once you set up your kind of bounding box, what's moldable for you, we're going to look at just the difference between a moldable part versus an unmoldable part. So with our first example here, we have this luer lock component that I have 2 separate iterations. So the top iteration has kind of a conical shaped through hole going through the center, and the bottom image has a straight through hole going through the center of the part. So the top part here, that's actually an unmoldable part. If we look at this center section, that through hole gets a lot wider in the center than it is on the ends, which is actually going to prevent us from having any sort of printed geometry going through the center of that luer lock component. So we're not going to be able to eject that geometry, so therefore it's an unmoldable part. So that's something to look for when you're designing any of these parts. You want to make sure that for any feature you design, you're able to eject that geometry straight out of the part. If you can't do that, then the part is probably unmoldable. For our second part here, we have this kind of capped part. So this one has some nice threads, a through hole. The top part ends up having a surface at the bottom, whereas the bottom part is completely open. This surface at the bottom for the top part, that's going to, again, prevent us from ejecting any sort of geometry that's inside of this part. So therefore, this would, again, be an unmoldable part. So once we've looked at, what's moldable, unmoldable, we've figured out our limitations for our setup, we can kind of go into start planning out what our design might look like. So this is an exercise that I like to do before I design every mold. It's once I have my base part, I've identified that I can mold it, and the part is moldable. I like to ask myself a few questions so I can set myself up to be successful in my design. So these questions are going to include, what's your target material? What are the number of cavities for this mold you want to do? Are there any draft requirements in this part? High risk features, what are those? Looking at sharp corners. Does a full redesign need to be done? That's kind of important because you want to do that before you start designing the mold, if that's necessary. And then start to think about the mold layout a little bit, like, is this mold going to have inserts? What's my ejection strategy going to be? So we'll go through these with these next two, or with these same two parts again, but this list is not the full list. There are certainly other questions that you can ask yourself, but these are kind of the main basic ones that I like to think about. So for this part here, this cap, it's probably going to be molded out of some sort of nylon. So I picked the nylon 6.6, and I wrote down the shrink rate for that material. That's going to be important in a little bit when we actually design this part. We're going to need to account for that shrink rate when the part's being molded so that we can properly scale and account for that. For this example, I'm going to go with a 1-cavity mold. That's just going to make our lives easier. And then for draft, I'm going with a generic requirement of 2 degrees of draft. Sometimes you'll see more, you'll be allowed to use 3, maybe more. Sometimes it'll be less, 1 half degree of draft, but it's good to know what that requirement is before you go ahead and design the mold. For this part, the highest risk features we're looking at, it's going to be the thread section and this through hole here. It's good to keep those in mind, especially later on when we plan out our inserts. Just as a check, there are sharp corners in this part, so if possible, we're going to want to remove those sharp corners with either a chamfer or a radii. With this part, no redesign is needed because it is a moldable part. If we were given one of those unmoldable parts, that's when we would need to do a redesign in order to create that moldable part. For inserts in this part, we're going to need 1 insert with this thread section, and that has to do with the ejection strategy. So in order to kind of be agile with these printed molds, one thing we like to do is hybrid ejection strategies, where part of the ejection is going to be an automated process with ejector pins in the machine, and part of the process is going to be manual. So in this case, we're going to actually unscrew an insert from these threads. And that allows us to avoid having to purchase or source an expensive actuated component that would automatically unscrew those threads. That's just something that it works, but it doesn't really jive well with the whole idea of being agile with a 3D printed mold. Alrighty, so we'll go through the second part as well. So for this material, lure lock component, we're going to go with a polycarbonate. So our shrink rate here is going to be 0.6%. With this tool, we're going to end up designing for 2 cavities, so we'll be able to go through balancing out runners and things like that. Draft requirements here, it'll be 1 degree, which, since most of the part is circular, that's not a huge consideration, but there are some flat walls that we'll need to account for. What are the highest risk features here? So it's going to be that center through hole in the part, and then the small ribs are going to create the actual lure lock fitting. So we'll want to just keep those in mind when we're designing the mold. Are there any sharp corners here? No, not really. It looks like whoever designed this part already included some radii on a lot of the sharp corners, so we should be all set there. Again, this part's moldable, so no redesign is needed. And inserts, we're going to do another insert in the through hole section here. So I can speak on this a little more later, but this is going to allow us to really make this feature robust and allow us to use potentially 0 draft in this area. And our ejection strategy, again, is going to be hybrid, where we eject the parts off of the mold with ejector pins, and then we'll do a secondary operation to remove the center pin throughout the part. Okay. So we've gone through our design planning stuff. Let's actually modify some parts here. So we're going to start out with this cap. You might notice that I have 3 surfaces that are red. So these are going to be our potential parting line surfaces. So before you modify a part, you want to know what your parting line is going to be so you can make all of your modifications based off that parting line. And what is a parting line? The parting line is essentially going to be the center plane of the part, and that's going to line up with the center plane of your A and B blocks for your mold. So all of your drafting operations and things like that are going to be done based off of this plane. So with this part, we have 3 different candidates for our parting line. We have these 2 surfaces here, and then our bottom surface. So quickly, we're going to go through the pros and cons of each surface. So for this bottom surface here, this could be our parting line. If that were our parting line, all these interior features here would be in our core half, and then all these exterior features here would be on our cavity half. So we could do that, but one thing I want to consider there is that this core feature is going to be awfully tall, and there are going to be features above my threads. Now, I don't know that I want to rotate this feature along with these threads, so I don't know that that's my best parting line. We could look at this to be our parting line, and that's going to end up essentially being the same deal as this base parting line here, where the full core is going to be this full through section, and then the exterior of the part is going to be our cavity. Still, it's not really what I want to do. I could go with this center plane here as well. If I were to go with this, then on my core half, I would essentially just have my threads and they would end at this face here. And on my cavity half, I would include this, these two faces here. So I'd have a nice smaller core section, or a core feature on my cavity half, but essentially I'm splitting up that core. So it's not as high of an aspect ratio of a feature. And I'm not really rotating it at all when I'm trying to remove the part. I'm just doing a straight ejection off this core. So I'm actually going to go with this as my parting line. So all my drafting and whatnot is going to be done based off of that. So we'll remove those. So I have my parting line identified. First thing I want to go ahead and do is add draft. So we'll start out with this top section here, and then we'll move on to the bottom section. But we'll go ahead and actually select these surfaces, and we'll draft them. So since I made this my parting line, that's going to be my reference plane for my actual draft operation. So we said 2 degrees of draft, we'll apply 2 degrees of draft. And if we look at the part, Creo automatically went to a draft that created a negative draft on this feature. So we'll just go ahead and flip that. So we have a nice positive draft so that we're able to actually eject out of this section. Now we'll go ahead and add some draft on the base section here. Again, the same deal, selecting this red face as our parting line, and we'll apply 2 degrees of draft here. Perfect. So if we take a front view of this part, we have our parting line here. We want to make sure everything has essentially an angle that's less than 90 in reference to this surface or plane. So if we look at these parts, the angle here, I guess I can't take that measurement, that's a bummer. Let's do a quick sketch. We'll take our angle, 88 degrees. So that's less than 90. That means we have 2 degrees of draft on this surface, 2 degrees of draft on this surface, and everything's going to eject nice and smoothly. So we'll close out of the sketch. Okay, so we have our draft applied. We're all set there. I'm not going to be applying any draft to the thread section here, because we're not going to pull straight off of those threads. We're actually going to rotate off those threads. So we don't really need to apply any draft there, because this is just going to unscrew like a screw might. So we're all set there. Now we're going to go ahead and we'll add in some radii in these sharp corners to help break them up a little bit. So really what I'm seeing are, reduce that value a little bit, but interior and exterior here, and then exterior there. Everything else is actually going to be fine. So this sharp edge here, this is where the two mold halves are going to meet. So since the mold halves are meeting at that point, you don't need to add any radii to that feature. Same thing with this interior edge here. Mold halves are going to be meeting there, so no considerations need to be made about radii. What I will try to do, if possible, is I'll get a little radii. Oh, that's just going to mess it up. So we'll cancel all of that. So we're all set with radii in this part. We know exactly where our inserts are going to be. So at this point, we've modified this part for the injection molding process, for the Fortify injection molding process. The last step here is going to be to apply a scaling factor. So we'll come up into our model operations and we'll actually scale the model. So we said before that we want to do 1.5 degree or 1.5% scaling on this based on the 1.5% shrink of the nylon. So we'll go 1.0.015. So that'll get us our 1.5% shrink. That it's going to count for that value. So at this point, this part has gone through the motions. This part is ready to have a mold designed around it. So we'll go ahead and save that. And I guess we'll run through the other part real quick. Okay. So we have our lure lock component here. Let me hide some sketches. Alrighty. So for this part, there's a couple different parting lines we could select. We could select this base face here. We could select this face here. Both of those are going to require some sort of side action component or insert to create these tight ribs. So rather than that, I'd rather have these tighter ribs on both the A and the B half respectively, so we don't have to do any inserts around them. So what we're going to actually end up doing is inserting a datum plane. It's going to end up going right through this part here. So what this datum plane is going to allow us to do is just capture both of these features in the A and B halves of the mold, and then we'll create this center geometry as an insert. So we have our parting line in place. We already have our radii in place, all that good stuff. So let's look at this center through hole here. So right now, this through hole does not have any draft on it. So we could have had some draft, but I would almost rather use a metal core pin for this feature. So what that's going to do is eliminate any risk associated with molding this feature whatsoever, because we've gone from printed material to metal. On top of that, it's going to allow us to maintain zero draft in this feature, which is typically desirable for part designers. And then finally, what's really good about this feature is it's an off-the-shelf component with any sort of supplier. So you're going to be able to source this with overnight lead times, essentially matching the speed of your printing process. Anytime you have to source some sort of metal insert that takes longer than your printing process, that's something you want to avoid. But if you can do it in the same amount of time as your printing process, then it makes a lot of sense. So we'll have our center insert going through here. We have our parting line identified. All our radii, our sharp corners are broken. So the last step again, we'll go ahead and scale this model. So this time we're going with a 0.6% scaling factor to account for the shrinkable polycarbonate. So we'll apply that. And we are all set. So at this point, we have two parts that are both ready for the mold design process. So from here, we'll jump into our next module.